So Dwayne's house is dried in now, and that means that I can get back onto some of my projects. We've got Sharon's house dried in, Sam's house dried in, Dwayne's house dried in. So now I can get back on my things. And one of the things that's been first and foremost on mine and Mama D's mind has been our biodigester, because right now this is our toilet, and it's not a lot of fun because we have to dump it, and then if you are carrying it on the uneven ground and you trip and fall, I'm not even going to go into the details of how that goes. But the biodigester is something that we've really been looking forward to. We're going to make it out of mostly 6-inch PVC pipe, and I've got a technical video that I'm going to have online, and I'm not sure which I'm going to put first, but there's going to be two videos. One's going to be technical, and the other one's going to be the operational or the assembly of it. And the technical one will describe how it works and how, you know, all the technical details about it. So we're really excited to get started on this. If you have any questions, feel free to post them. If this doesn't work, which I know is going to be a common question from a lot of people, what are you going to do if it doesn't work? Well, Sam's got a porta potty at his house, and I will call the porta potty man to come pump this thing out if it doesn't work. And the way that I'll know it doesn't work is if one of two things happens. One of them is if I never get any methane gas out of it that's burnable, I know it's not functioning. And secondly, whenever I take the effluent out of the other end to the University of Hawaii Hilo to have the water effluent tested, if it comes back positive for fecal matter, then I know it's not digesting properly or completely. We'll also need to monitor the pH and that kind of stuff. So we're looking forward to doing this, and glad to have you along. Nothing like chasing turds across the lawn.
I didn't even know what off-grid was until I met the love of my life. I followed him to a mountain in Colorado, then we ditched the cold to build our new home in Hawaii. Follow us as we tour the Big Island, discover all the wonderful cultures here, and help others with their dreams. We are living off-grid, really.
Alright, so this biodigester design that I've come up with is basically evolved after all my research and figuring what hasn't worked in the past, what has worked, and some things that has been done that just didn't make a lot of sense to me. I'm trying. One of the things that I know is that when you have a septic system with a septic tank, all the way up until the early 2000s, mid-2000s, or middle 2010s, whatever, a family of 4 or a house with 2 bathrooms would get a 1,000-gallon septic tank, and everything goes into that. The washing machine, the sinks, the bathtub, the shower, the toilet, everything goes in there. And so it has to process all of that, and it's non-discriminate, because the only person that's going to control what goes in there is you. So if you flush your prescription pills down there, it's going to upset the balance of it and all this kind of stuff. So septic systems are just not a real good solution for sewage treatment. And recently India has gotten into biodigesters in their country, because it's one of those things that completely processes all of the effluent and the sludge and slurry, processes all of that, breaks it all down, totally digests it. So at the other end you have very high quality fertilizer that comes out, and you have methane gas. So the methane gas is usable for cooking, you know, anything that you need a flame for, you can use the methane for. And one of the things I was a little bit disappointed about is that unless you have a commercial system that's got all of this temperature control and all this kind of stuff, the gas production of it is very low. It doesn't make a lot of methane gas over time. I thought that instead of just running everything into the biodigester like you would do a septic tank, I would run just the toilet in there. And then I got to looking at toilets, and you know, you can get most of them that'll use 1.1, 1.2 flushes, or 1.2 gallons per flush. And that was still quite a bit, because if I figure that just the two of us, Mama D and I, that we're going to flush probably an average of 4 times a day. So 1.2 gallons is still going to be 4.8 or almost 5 gallons a day that goes into this thing. So I was kind of looking around on the internet at different toilet options, and I found these RV toilets here that are very, very efficient as far as the flush goes. And we settled on this one that's made by Dometic. It's the Dometic 300 series. It says it's just like home. It has a standard seat. It mounts to a standard toilet flange in the floor. The bowl is porcelain, not plastic, so it's, you know, it feels like it's pretty much a regular toilet. One of the things that I really like about it here, see if I can find, yeah, here we go, where it says "and more" here. You can see here it says water efficient flush, uses just 1 pint per flush. And one thing I can say is that if it's urine, doesn't even use a pint. You know, it uses maybe a quarter of a pint, just very little, a cup or so. But when it's solids, it can use a pint. It can use a little bit more. You know, if you get racing stripes in there or whatever, and you need to kind of get them rinsed down, it could take a couple of pints, but it's still very efficient. So I've calculated the volume of the biodigester based on 4 flushes a day, 2 pints per flush. So 4 times 2 is 8 pints per day. And computer, how many pints are in a gallon?
1 gallon is 8 pints. Other customers have also asked, how many cups are in a gallon? Would you like to know the answer?
No. So anyway, one of the things that I did now is, instead of having to accommodate nearly 5 gallons of water per flush, I only have to do 1 gallon per day. So 5 gallons a day, almost 5 gallons a day, as opposed to 1 gallon a day is what I've moved down to just by changing out the toilet. Now all the sinks and the shower, those things all go out straight to the banana trees, because that's going to be like soap suds, and it's got all those phosphates and, you know, all these things that break down into really good fertilizers that the banana trees like anyway. So all those just go straight out to those banana trees. All we're worried about here is just the effluent that comes out of the toilet into the biodigester. So one of the things that I did was, when I was researching, I was looking at how these things would go. And let's zoom this up just a little bit. So you see here that we've got the inlet where all the little turds come down into the tank, and then they come out at this end, and you've got fertilizer at your outlet. Inside you have your composting tank, the scum, and then the gas is collected at the top. That's the methane. Well, the thing about this particular design with the single stage is that when this effluent goes into this pipe, it's pushed in, and of course once it gets moving, it's going to continue across this way. Well, what happens here is this pipe, it's pushed out, and when you've got everything pushing out this way, it's drawing from the tank. So as it's pushing in here, it's pulling out here. The problem that I have with this is that I think that some not completely digested fecal matter could actually find its way to the end. Well, what they did to fix that in one design was, see if I can find it here, this guy right here. Okay, so this guy, you have your inlet pipe that goes into the bottom, and then you have a baffle in the middle, this partition wall right here. So it has to go in, up, over, and then back down and out of this outlet pit. So whenever you've got this going on here, there's not as much of a chance as the fecal material getting from the inlet to the outlet as directly as it would happen with the single stage biodigester. So then there was another one that they tried in this this next set here, and they've got this one biodigester here that, you know, the effluent goes in, it comes out just like all the others, but then you have this stirrer that would either be operated manually or it could have a motor up here that would just sort of mix all this stuff up. Well, you're mixing all the old with the new, so in my opinion you still could have some of the new effluent that's basically fresh turds coming straight out of this guy into your outlet, and you know, there could be some pathogens in with that. I don't like that. And finally, we've got this last one here that I believe a municipality hired an engineering company to build this one. And this, I think, was like a polyethylene kind of a tank here. They put it on a concrete pad with a heat exchanger that heated up all this effluent so that it would make the gas faster. So they would pour the manure into the reception pit, the pump would turn on and force it into this thing, and then they'd have these two little propellers on either side, which were mixers, and the effluent would come in here and just sort of swirl around and not necessarily make its way to the outlet of the tank. Now, what I don't like about this either is it's using electricity for the pump and it's using electricity for the mixers, and when these mixers break down and have to be replaced or repaired, that I don't want to be the one climbing in the tank, and whoever does it's probably going to charge a lot of money. So I kind of just started moving away from that kind of thinking altogether. So I got to thinking, you know, well, the human intestines is probably the best example of methane production, because you eat and all of that organic material, food as you want to call it, that travels through your intestines, then our intestines extract the nutrients out of all of that food as it's passing through the intestines, and we generate methane gas, which is good old smelly farts, and and then of course you have your effluent that exits out the end, but it's not completely digested because our body only needs to have it in the intestines long enough to pull the nutrients out. The goal is not to completely digest all that fecal material. So if we look at our intestines here, this is kind of what we have. We got the stomach, and it comes in and it goes through and just squiggles all around all these different directions here, and then finally goes out the rectum. So it's a pretty efficient biodigester. It's just that the organic material doesn't stay in there long enough to get totally digested. So I got to thinking, well, I could take some pipe and make basically an intestine that just sort of zigzags around on the ground there and let that fill up. So what I needed to do at this point was do a little bit of research. One of the first places I found on the internet was solarcities.eu, and they had a pretty good article here about biogas and biodigesters and all of this kind of stuff. So I was looking at this, and it says that from a 275 gallon home digester, you should make 1 cubic meter of biogas in a day. As I've researched a little bit deeper, that's true if the biodigester is thermally stabilized. In other words, it's kept at a warmer temperature, typically around 90 degrees Fahrenheit. You know, this thing here, and it says that here, it says the problem usually is temperature. Most biodigesters seem to have a slurry and then normalizing at about 20 degrees Celsius. These only produce 1 to 300 liters of gas a day. at 25 degrees Celsius, you start topping 300 liters a day. And at 30 degrees Celsius, you may be looking at 500 liters of gas. And then body temperature, you see a theoretical 1,000 liters. Again, I'm more interested in the very low tech. The slow style is fine. I've got plenty of real estate out there that I can work with. So I'm looking at doing the lower temperatures, like around 20 degrees Celsius, which is around 70 degrees. So anyway, I finally found this other site out there that is very thorough, and it's flandershealth.us. And they have a very in-depth article about biodigesters and how they work and all this kind of thing. So my particular need to know in this case was, how long would it take from the time that I flush a turd down the toilet that it comes out effluent at the other end and it's totally digested without any possibility of any fecal matter still being there? So I'm going to click on the temperature tab, go into that, and down here, so we've got what's called these different types of bacterias. So you got what's called the psychrophiles that operate from 5 to 25 degrees Celsius, which is really low, like probably 30 degrees up to 75 degrees Fahrenheit. And then you've got the mesophilic bacteria that operates from 30 degrees Celsius to 35 degrees Celsius. The thermophiles, which really make a lot of methane, has to be kept at 50 to 60 degrees Celsius. And then you've got the hyperthermophiles, which is greater than 65 degrees Celsius. Those require commercial equipment and all kinds of monitoring systems, and it's just a real big pain in the butt. So anyways, we're going to be looking at using the psychrophiles bacteria to process our waste into methane. So right here it says the more difficult the press temperature of the biodigester sludge, the sludge retention time is usually long, often greater than 12 weeks. Well, 12 weeks, that's, well, let's see here. We've got 1 gallon per day, so that's 7 gallons a week, and 7 times 12 is 84 gallons that my biodigester would need to hold to operate at a minimum of 12 weeks for 4 flushes. Now, more realistically, we're probably going to be doing more like I would guess more like 3/4 of a gallon, probably closer to 3 flushes a day, because we really don't depress the pedal for very long to flush. Okay, so I got this pipe volume calculator, and at first I thought, well, I could probably do all this with 3-inch or maybe 4-inch pipe. And whenever I realized how much it was going to take of the 3-inch pipe, it was way outside the scope of reasonability for me. So what I did was I moved up to the 4-inch, and it was pretty much not any better. And I finally went to 6-inch because Home Depot sells the 6-inch pipe. And so a 6-foot diameter, 10-foot long pipe will hold a little over 14.5 gallons. So if I go back over here to my calculator, I can do 14.5 times, and I've got actually 11 sections of pipe out there, which is 160 gallons easy, because I've still got the elbows in it, the stack, and all this other stuff. So I'm easily at twice what I need to have in order to properly and fully digest fecal material. There's a lot of other things that needs to be taken into consideration with biodigesters, like if you fill them with too much water, like you do laundry or whatever, and you're using it for all your sewage, you get what's called this hydraulic saturation or basically waterlogged is what it means. They like using these big words in these papers. But the simple man's term, it just gets waterlogged. There's so much water in there and everything just gets so diluted that it can't process very well. Where my system is a lot more concentrated, a lot less water and more of the fecal material that's actually in the piping out there of the biodigester. And other things that you have to take into consideration is the pH of the biodigester. You got to kind of watch it a little bit because over time the biodigester will start to kind of acidify a little bit, and you might have to add a little bit of, just a little touch of borax or baking soda or something like that. But as long as you keep it fed with other organic material like toilet paper, cuttings from the kitchen, any kitchen scraps, that kind of stuff, all those kind of help keep that thing balanced out a little bit. So all those help a little bit. I'm just going to go through all this right quick. I shouldn't have a foam issue because I'm not doing any mixing or any of that kind of thing in there. Alkalinity, we kind of talked about that because urine breaks down into ammonia. And urine initially is rather acidic, but as it breaks down and turns into ammonia, that becomes more alkaline. So, you know, too much of anything kind of messes it up. You want to try to have a good balance of it all. A lot of fatty acids. There's things that can be toxic to your bacteria in the biodigester. Here we are in retention times. Let's see if I can find that again. So retention times in an anaerobic biodigester. So you have solids retention time and hydraulic retention time. And in this world it should be that solids and hydraulic, or the solids and the water, should all be pretty well blended by the time it hits the other end. And it should be just really good high quality fertilizer. So you can see here that, you know, if you've got a high powered biodigester, you know, that you can run your effluent through there in about 12 days, where in my case it's going to be more like 12 weeks. You know, you want to be careful about the washout and the too much waterlogging, that kind of stuff. Shouldn't have that problem with mine. Here we've got upsets and unstable digesters and how to deal with those. So a lot of really good information in this article. And it's, you know, it's very in-depth. And I could sit here and read it all to you and go through each detail, but it's not really, you know, most people are going to get bored with all the details. So that's the reason I'm just hitting on the things that I feel that are important to my installation. Although all of it is important, I just have to be careful about how I come in here and get it where it's just so boring that nobody's going to watch. Alright, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 6-inch PVC pipes that is going to make up the components of my linear biodigester. And it's not going to be just pipes. So there'll be a lot of fittings that'll make it up. And then I've got this spot right here. The white pipe on the ground here is going to be the effluent that goes into the biodigester. And the black pipe to the right of it is just simply gray water from like the shower and the bathroom sink. And it goes down there. And at the bottom, all along there is where I'm going to wind that white pipe back and forth until I've gotten all that pipe used up. So the effluent will come in at this end right here, flow down and work its way around, and finally end up at those banana trees over there as fertilizer. And then I'm going to collect the gas up here closer to this area, and the gas I'll put into a storage bag that will have the gas stored in it. Okay, this is the soil stack that goes directly from the toilet down through the pipe all the way to the biodigester from here. The gases from the biodigester will travel up the top side of the pipe all the way up here, and it'll pass into this pipe, which is the collection point of the methane gas. And I've got it stubbed out here. I'm going to come up with another pipe and some adapters into smaller pipes, and we'll collect all of it into that, and then we'll use that for running our clothes dryer initially, if it works well for that. So we've got all of this set up and ready to go. Now it's time to run the biodigester. So I'm working on the gas collection port, I guess you could call it. This is the port that the gas will come out of the biodigester. And I'm going to reduce this 3-inch pipe down to a 1/2-inch pipe, and the gas will collect through that 1/2-inch pipe, and it's going to be very low pressure, very close to atmospheric pressure. There's not even going to be 1 psi. It'll just go into a collection bag of some sort eventually, and I'll probably put it inside a wooden box so that the cats don't get to it and claw holes in it. And that's what I'm going to work on at this point. So I'm happy to have you with me, even as bright as this sun is. It's a great sunny day. I think that's just about got it done before this next drain starts. So now we'll just start letting this thing percolate and see what happens. Alright, this is the completed biodigester. And it starts here. This pipe is the one that goes directly from the toilet. So it feeds directly into the system and goes out. And it's got a very slight angle. It's got that one right there that goes straight down, but the rest of it is just a very gradual slope. Even out there where it winds back and forth, it's a very gradual slope. So that way, when you flush the toilet and everything goes down, it forces all the other material that's in front of it out. And I'll go down and explain all that in a minute. And then this here is the methane capturing stack. This is where the methane is captured out of the system. So as it's digested down there, the bubbles rise up to the top, make their way back up this pipe, all the way up here. And then it's captured in this Y right here. And then it's brought right out, and it goes into that PEX pipe. Right now that PEX pipe is just going into a bucket of water, and that's to isolate this system from the oxygen in the air. That allows the methane bacteria to start growing. Alright, now we'll take a walk down here and we'll look at all of this a little bit more closely. Alright, so now you can see the pipe here. I've got to raise that one up right over there, that one loop. It's a little bit below the others, but it's coming up, and then this, so you can see that it goes in here, goes into the 6-inch pipe, makes its way around, all the way around. That's what makes this a linear biodigester. Nothing comes out the end until it's gone all the way through all of that pipe. And then at the very bottom right here, it's got an elbow. And then the sludge that's at the bottom is forced up, out, and over. And then it comes across here and feeds the banana trees. And that's supposedly a really high quality fertilizer. The plug up on top is so if I ever have to inspect it or pump it out, I can take that off. Hopefully I'll never have to have it pumped out, but if I do, I've got a way to do it. So that's the completed system finally. Now the reason that this stack right here is as tall as it is, that's about probably 5 feet from the ground here up to the tee. And the reason for that is I want it to be right at the same level as that gas pipe where the first fitting meets. And that way the liquid and all of the pipe is in there all the way across. And the liquid that's in the pipe, all the slurry, is what actually seals the system and keeps it from getting to the oxygen in the air. So now I've just got to fill it all up with water and start crapping a lot, and then I should have some methane here in about 15 weeks if my calculations are right.